Welcome. The stream will be starting shortly. Welcome to Microcontrollers with kingernorth. I'm your host, kingernorth, and today we're going to have episode 8, and we're going to be doing push buttons and touch inputs with CircuitPython and Arduino. So again, welcome aboard. Let us have a look at what we're using today. Today we're going to be using a number of devices, and we're going to be using the Arduino Uno to program with it. We are going to be using a Adafruit Feather M4 Express to also do programming in CircuitPython. And I have another board here. I have this round board over here. This is the Circuit Playground Express. And I just want to talk about that when we get to a certain feature later on in the video. But then I've also got a few other devices around here too. I have a switch up here at the top. I have a standard push button. And these you'll see a lot of times mounted into panels. And this is a nice big push button. This is actually a fairly decent quality one. The cheap ones, most of them look very similar, except they usually have more plastic. That's actually a pretty decent quality push button. This is a pretty good quality switch. Then there's other items here. There's a little slide switch over here. You just slide it from one side to the other. And of course, then we have a push button here, and this one actually is colored, but it also has backlighting too, so you can actually have it lit up when you want. It has 4 connections on the back. And the reason for the 4 connection is 2 is for the contact on the push button, and 2 are for the actual light itself. And this is I believe this is a standard 5-volt light in here, which works with most of our microcontrollers. But we're not going to be hooking those up today. But I just thought I'd show those as other input devices, because we have lots of choices when it comes to all of this type of stuff. Hello, Walter. Welcome. Yeah, you can stay as long as you need to, and you can always come back and watch it again later, the rest of it, so no problem with that. So we're going to go ahead and we're going to get started, and we're going to set up on our main screen, and today we're going to start with the Arduino. So I'm just going to go into here, and let me move some of the other things out of the way, and that way they're not going to be distracting, and we're going to zoom in on the Arduino board a little bit more so we can see what's happening here. And I want to talk about what's going on here, because this is your standard Arduino Uno board. Pretty straightforward. I've already pre-wired it. I have a push button here, a fairly big contact push button. I have a little rubberized one in here, and then I just have a wire connected. And this is for using the touch, or could be possibly touchless depending on how you set it up, type of setup. And we also have a couple other devices. I got a couple of resistors here, and I have some wires, and I have power going back to the board, and I'm running 5 volts here. What I want to do is I want to talk about how these circuits are wired up, because you can set up inputs a lot of different ways. And even though it's just a simple push button, we'll start with the push button circuit. So even though it's a simple push button circuit, we actually have quite a few choices. So let's have a look here at our standard little circuit. So what I have here shown on the page is I have a picture of a controller. I happen to be using pins 9, 10, 11, and 12 are what I'm showing. And I've connected 4 input push buttons to this board. At the top on pin 12, I have a 10,000 ohm resistor. That's what 10K stands for, 10,000 ohms. And I have it in series with a push button that's connected to the 5 volts. This is how we would normally have something if it was connected in our home, for instance. We would actually go to the power, go through the push button or the switch, go through the load, which in this case is 10K, and then go back to the common, which it actually feeds back through pin 12 on this. Unfortunately, this doesn't work very well for or miniature electronics. They don't like this setup because what happens is, and right now the button is showing as not being pressed. And what happens is we really don't know what the voltage is on that 12. We don't know how much stray voltage we're seeing there or induced voltage from other components in the area. So that's a real problem with electronics, the way they're set up. So let's move on to, so that's not the preferred method. We would prefer not to do that in these microcontrollers. The second method, number 11, is actually a fairly common method. And what we've done here is we've gone from the 5-volt rail, which 5 volts if you're using Arduino. It'll be a 3.3 probably if you're using CircuitPython on one of the other types of boards, like the feather board like I use in the other one. So it'll be whatever voltage is normal on your microcontroller. I come down through a 10,000 ohm resistor, and I go back to pin 11. What that essentially does is I'm actually connecting 5 volts to pin 11 at this point, because there's nothing else in the circuit. The push button down below says pull up push button is actually not being pressed. So when it's not being pressed, I'm going to get all 5 volts going into pin 11. I'm just going to get it at a reduced current, and that's what the 10,000 ohm resistor does for me. Reduces the current just so I don't put 5 volts directly into the pin without anything inside of it. So it just limits the load. But then I use the push button, and when I push the push button, the voltage drops to 0 on pin 11. And the reason for that is because the push button is connected to the common rail. And again, that's the common rail of your controller. So what happens is it creates a dead short between pin 11 and common. So now the 5 volts comes down, it goes to it tries to go to pin 11, but it's going to go to the path of least resistance, which is the common rail, so it goes down through the push button, and the current flows in that direction. So 11 looks like it's grounded or connected to common. So it looks and sees a low signal. So that's what a pull-up push button does. You have an external 10,000 ohm resistor. The next one connected to pin 10 is what we refer to as pull down, which we actually don't see as often, but some microcontrollers allow you to do pull down when we get to the last one. But if you wanted to create a pull down circuit, what happens here is pin 10 is now connected across, and it is connected over to the voltage rail, so it can sense 5 volts coming in. But what happens is we have 5 volts coming in, and then what we do is we have a 10,000 ohm resistor going to ground. So we can short it out. We put full 5 volts into pin 10. But what happens is we also run a small current down to the common rail. But what happens is 10, instead of seeing ground, is we see power when the button is pressed. Now the reason for the 10,000 ohm resistor going between pin 10 and common is so that when we let go of the button, it references back to ground, and we don't get a floating signal like we did on pin 12. We get a known 0 volts or very close, or considered to be a low voltage input coming into pin 10, which then it works with that just fine, and it has no problem working with it. All those methods work. First one on pin 12, not so good. Pin 11 is more common. Pin 12 or pin 10 is very common. But pin 9 is our preferred way of setting it up with this modern electronics with microcontrollers. And connected between pin 9 and common. There is no power connection connected to it whatsoever. In fact, what happens is when we had a pull up, we had a resistor between power and the input pin. When we had pull down, we had a resistor between the pin and common, the input pin and common. What we can do on a lot of microcontrollers, and most of them, have what they call pull-up. You can do an internal pull-up, which means it actually turns on a little switch that allows a high ohmage value resistor to be connected internally to it and supply 5 volts on pin 9 in this case. And when we press the button, we're grounding it. So we only need that one portion of the circuit. We don't need the resistor. Some boards, like my CircuitPython board, will also allow for pull down, which then gives you the other circuit. So it actually is connected to ground, and when you press the push button, it completes the circuit, but it's wired up the exact same way. It's just gives you the opposite result as the trigger. And I'll talk about the pros and cons of that, because there is a little bit of Boolean logic that gets involved with reading inputs when you're doing this to understand how it works. So that's your basic setups. The connection on pin 9 is preferred, and you can either use pull up or pull down, which connects it for you. Then you've got, and in fact pull up is the most common used, because you don't need a power connection. Ground works really good, so that's ideal. And then of course with the other methods, you could do external resistors if you don't want to use internal resistors. But why not take advantage of the internal resistor? It's one less component you have to put on your board. So let's see how this works. So I'm just going to turn that diagram off for the moment, and we're going to go back to our board. And what we're going to do is we're going to build a circuit in here to use just this first push button. This first push button is wired with an external pull-up resistor here. In fact, actually, if I look at that, it's actually a resistor that's connected to ground, and my power goes to the push button, so that's actually that's a pull-down circuit. That looks like a regular pull-down hardwired circuit. So if I went back to this other drawing, what I'm connecting is number 10. I'm doing the input as if it's wired the way it shows here on number 10. So let's create some programming for this. So for the first thing we have to do with our Arduino sketch, of course, let's save it, and let's create a new file here. So I'm going to go File, Save As, and we're going to give this a name once we get it in the right spot, because we're going to go into our documents. There's documents, and we're going to go in today's shows notes, electronic show, and we're going to go to basic inputs, and I'm going to create a new sketch here just called or just space test. So this is my push button test. So that's all I'm doing here, and I'm just going to save that. It's now got the name up here at the top, and we're going to go ahead and we're going to put a quick comment in here at the top. This is a simple push button test, and that just satisfies it, and we've got something at the top, and we don't have to go any further with that. The next things we're going to look at is we're going to look at any helper files we need. Well, this is just a simple input, so we don't need any helper files. So we're not going to have any helper files to include at this point. So what we are going to do, though, is we are going to do some pin assignments. Because what we're going to have to do, there we go. So what we're going to have to do in the pin assignments is we're going to have to set up where we're connecting this thing. And in this particular case, I have push button 1. I have it connected to actually input 4 is what's on that board. So way over here, this is actually input 4 that I've got the white wire here connected to. So that's what I'm going to do here. So I'm just going to create that pin. So input, and this is going to be PB1 equals 4. So that just tells me that I'm connected that to pin 4. Now something else I'm going to need to add is I'm going to need somewhere to show my work where it's being done. So I'm going to create another input, and actually that should be push button pin. Let's keep that straight. And this is the pin for the LED, and we're going to attach that to 13. Now the reason why I'm using 13 is a little LED that's already here on your board. That it's right there above my finger, and that is pre-connected for you. That's most of our microcontroller boards that we tend to use have something like an LED built in that you can use without having to physically connect one. So we're just going to go ahead and use it, and we'll see how well we can see that. But I think it'll work fine for this demonstration. And for you at home, this would definitely be fine. But this just saves me having to hook up an LED somewhere to another pin externally. And that's all that's for. So that's the first thing I'm going to do. And then the next thing I had to do is I'm going to set up any variables that I'm going to use. any variables that I'm going to use with this program. So I'm going to come down here, and this time I'm going to set up an integer value for PB1, and this is what I'm going to do. I'm just going to start with it equal to 0, and I'm also going to set up that's it. Actually, that's all I'm going to set, because I'm only setting up one push button. I don't need to do anything else with that. So now what we need to do is we need to go into our setup here. So let me get rid of this comment line here, and what we're going to do is we're going to have to set up a couple of different things for us to use in here. And one of the things we're going to be doing is we're going to have to set up which pins to use. So in Arduino language, we use pin mode to assign the pins a function. And we're going to put in here PB1 pin, because we're going to use the name from up above. And we're going to say that that's going to be an input. So this is just a normal everyday input, nothing special. This is just an input. This could be anything coming in at this point, but we're going to keep it simple. And the other thing that we want to set up in here is we are going to set up our LED pin. So I'm going to set up pin mode, and I'm going to set that up as an LED pin, and I'm going to set that up as an output, because that's what we want it to do. You can actually set up that pin as an output, since it already has an LED connected to it. And we're just going to utilize that LED in our program just to make life really simple. So that's where we stand at this point. Now the next thing we're going to do, let's create some code. And basically what this code is going to do, it's going to say when you press the button, turn on the light. And that's really all we want it to do. We're going to keep it really, really simple. So what's gonna happen here is we're gonna have to look at that pin. So what we're gonna have to do is we're gonna have to go to that PB1, and we're gonna have to assign it a value now. So it was 0 was the default value up above, but this time what we want to do is we want to read the value that's actually on pin 4. So what we're going to do is we're going to go and we're going to put in a digital read. So it's going to bring back either a 0 or a 1 for digital read. It's going to bring back a number, and it's going to be 0 or 1 because it's either going to be true or false. And then we have to tell it what pin we're going to look at. And in this case, we're going to look at PB1 pin. So that's pretty simple. At this point, all we've done is we've turned around and we've read the value coming into the pin. Now we want to do something with it. So this is where I start with one of these if statements again. So if, in other words, PB1. Now I have a few choices here how to write that. I'm just going to write it like that, because what's this saying? If it's true, in other words, if there's a 1 on it, I want to do something with it. And it's as simple as that. I just want to do something if there's a 1 on it. And what I'm going to go down here is I'm going to go like this, and I'm going to fill it in. What do I want it to do? Well, I want it to turn on the LED. So let's go with, in this case, digital write for setting an output. And we're going to just talk to the LED pin because we already assigned it in there. If we change the assignment later to that pin, we only need to change it up in the top. We don't have to change it anywhere in our program or in our setup. So this just saves us a big hassle. So now we can turn on the light. The problem is it'll stay on because it'll always go to the last state. So what we need to do is we need to turn it back off again when we let go of the button. And I'm just going to come down here and I'm going to type in the word else. And I'm going to give it a secondary choice here. So this will be digital write. And in this case, again, this is LED pin. Oh, you know what? I got to put more into that other comment because you know what I've forgotten here? If we're going to write something, not only do we have to assign the pin, but we got to assign the condition. So I better tell this one's going to be low. So guess what I better do to the other one and fix it up? I better make that one high. And this is the way they prefer to do it in Arduino. They like to use the words high and low for setting the pin values. And high just means set it to whatever the voltage is of the microcontroller. And low means set it to common. And it just gives you something very close to high, very close to the voltage. If it's 5 volts in this case for Arduino, it gives output very close to 5 volts. If it's low, it's very close to 0 volts. Everything in these microcontrollers is just, you're going to be close to something. Does it have to be exact? Not necessarily, but our program. We start out by assigning the pins that we're going to be using. I'm going to be using pin 4 and pin 13. Then what I'm going to do is I'm going to set up any variables that are going to change while my program is running. I'm going to include the setup file. In this case, I'm going to include pin 1 for the PB1 pin for the input, and I'm going to take LED pin as the output. There's my inputs and outputs. Then when I get into my loop, which is the continuously running portion of the program, I'm going to read the value coming in on this PB1 pin, and I'm going to assign it to the value called PB1 that we created up here. So this is either going to be a 0 or a 1, this value. And then down here, what I'm going to say if, and basically this is saying if PB1 is equal to 1, and you could write it this way, or if you really want, you can add all that into it. And there, it's a double equal sign. A double equal sign, especially if you have a variable that has multiple numbers in it. This one here would be, you would read this as PB1, therefore, if PB1 is equal to 1. And that's is equal, being a not equals, just is equal. You're doing a comparison between these two values. But Arduino allows us to do a short form, and so do most languages. If we don't fill anything in afterwards, it just assumes that you want it to be a true. And true is 1. Anything other than 1 is false. Down here, if it's true, we do whatever's first thing in the if statement, and that is we're going to set the pin to high. In other words, turn on the LED. If it's false, and that's the else. So in other words, if it's not true, we're going to turn off the LED. So let's see how this works out. So first of all, I'm going to verify it to make sure I didn't make any typing errors, and it says compiling sketch, and it should come up with a done, and it does. The bottom of the screen did not turn, my cyan bar down here at the bottom didn't turn orange, so no errors, so it's happy. So let's make sure we're connected. We're going to come down here. It shows I'm connected to the Uno. So we're going to do that. We're going to go ahead and upload this sketch. So now I'm uploading that sketch into the board. It says it's done uploading. If it works, when I press this button, this little tiny LED over here is going to light up, and it did. Look at that. I press the button, the light lights up. When I let go, it shuts off. It did exactly what it was supposed to do. Now I have the external 10,000 ohm resistor over here. So that shows it like that first circuit did. Pretty simple. But I get a really good plus and minus out of this, which is really, really nice. So now let's use an internal pull-up. The second switch I have here, I have this other little push button here, this little black push button here, kind of hidden under the wire, but there we go. It's actually already wired up, and the way it's wired up, it is connected to pin, I believe it's pin 7. I'll just check my notes here because I don't want to move the board to read it. So yes, I'm connected to pin 7. And I have it the other side of the board, the switch push button, connected to ground. I have no resistor on it. So I've removed the idea of the resistor. So let's set up our pin assignment. So let's go back up here where our pin assignments were. And I'm going to add a new pin assignment. This is going to be for push button 2. And I'm going to say this is equal to 7. Okay, so there we go. So that's on pin 7. So the other thing I need to do is I need to set up my pin mode down here. Oh, I will need to do something else here. Yep, that's my pin. I'm going to have to create a variable for it as well. So we'll just follow the same pattern I did here, PB2 equals 0, just to give it a starting value for that pin. Let's set our input in here. We already set PB1 pin input. So let's just do that. Pin mode, and this will be PB2 pin, comma, and this time what I'm going to do is going to be a little bit different. It's input underscore, because I'm using the internal resistor now in here, I create a pull-up. I tell it that I want to do pull-up. What that does is turn on the internal resistance inside the chip, inside the main processor chip. It has one there, and it says, oh, you want an input pull-up? And it's going to do it, and it's going to draw that circuit like I showed in the original picture. So if we just remind ourselves down here, input pull-up is going to put a resistor between 5 volts and the pin, in our case, pin 7. And then we are going to connect the external push button from pin 7 to common. So we're going to do that. So that's what we're doing here. So what happens here is we're going to do all of this. That's all fine. So we're going to have to go into our main loop now, and we're going to have to read in the value of that pin. So I'm just going to go PB2, and this looks just like the rung above it. This is a digital read, and I'm going to tie this one here to PB1.pin. This is not PB1, this is PB2, since this is the other pin. So we'll keep that straight. And then what we're going to do is we could create another whole if statement here and have it turn on and off the light based on this. But what we can do is we can actually increase this if statement here. So what we're going to do here is, I don't care which push button is pressed, I still want that LED to light up. So I'm going to make my life a little simpler. And what I'm going to say is, if push button 1 or push button 2 is pressed, light up the LED. And the way we do that is we use the key above the shift or above the enter key on the right hand side of your keyboard, the double bars, and that means or. And that's what that means in there. So what we're going to say is that if PB1 is pressed, is true, or, now this is where it gets tricky. We're using an input pull-up. An input pull-up reverses the logic of the input pin. Because we have 5 volts connected to the input all the time, if we're not pressing the button, it reads a 1. If we press the button, we are connecting it to common. So we're actually going to have to look for when it's false is when it's pressed. And that's the hardest thing to get around in your head. So when you test this out and do this a few times, try it and you'll see how that works. Now, the way we do this in here is we actually we put in an exclamation mark and then use the variable PB2. And what that says to us is, let me move my cursor out of the way. It says if PB1 or, and this exclamation stand means the word not, N-O-T, not PB2, then we do the true, which is turn on the light. If it's false, we turn this off. So what we're doing is we're looking for, if either one of these is true, turn on the light. If one of these is false, then the whole statement's false. Or if both of these are false, the whole statement is false. So the only time the LED is going to light is if one of these are true. If PB1 is true and not PB2, it'll light up the LED. If PB1 is false and PB2 is true, it will light up the LED. So it goes back and forth. And you're only going to learn this by experience, and you have to hook it up and give it a try and see how that works. So we're going to go ahead and we're going to upload this to it. If I typed everything wrong, I won't get any errors when it checks it. It says it's uploading right now, so it seems to be happy. And now it's done. So let's just check to make sure. Yep, that little tiny LED up here did light up again with the first push button. But when I press the second push button, oh, look at that, magic. The magic of electronics. We actually can now turn it on with either push button. And the second one, of course, we didn't have to add any resistors externally. It's strictly just a push button connected from the pin to ground. In other words, to common. So it made it really easy. Made it really, really easy to use. So what happens next is we're going to add this third one in. And I want to talk about that because you've actually used these kind of buttons in the past, in the real world. Have you ever walked up to an elevator and touched the control button, but it's not really a button, it's just it's just like a little pad, and when you touch it, or when you get really, really close, sometimes you don't even have to touch them, the light comes on, telling you that it's been pressed. Even though it's not really been touched. You've only come close to it. That's referred to mostly in the world There's two types of touch, and that's capacitive touch and resistive touch. Capacitive touch is the common one. We can simulate capacitive touch within our program. So let me just explain with a picture here of what capacitive touch is. So let me go back to my drawings. And what I'm going to do up here is on my drawing, I'm going to switch to another drawing, and that's this one. So this is what a capacitive touch does, and it's a little bit different, and I need to explain this. So on the controller here, one touch button. If you had 5 touch buttons, you would need 6 pins. You need 1 extra pin. But what I'm showing here different is pin 9 is actually generating a signal. Pin 10 is receiving that signal back, is what it's seeing. And it's seeing the signal coming in. The signal looks like the top image there when it's not being touched. There's a whole bunch of little pulses that happen, and this happens within microseconds, these little pulses. And this is happening around, when I did a test, I actually hooked this up to my oscilloscope to see what was going on. And the sample file that we're using is the one that I tested. So what happens is, this is happening at about 4.5 kilohertz. So about 4.5 thousand hertz, this thing's pulsing. And what it does, it pulses a bunch of times, then it takes a little pause, and then it pulses a bunch more little times, and it takes up a little pause, and it does that, and then every once in a while it takes a long pause, and then starts the cycle over again. During the long pause, it recalibrates itself, because capacitive touch is affected by humidity, temperature, a number of different things in the real world. And unfortunately, it's not always easy to understand, and there's a little bit of electronics here, but basically that's what happens, and it has to recalibrate itself. And it's best if you let it recalibrate itself. So what happens here is it reads this signal. Now, what happens is when the signal is when you touch it, where it says touch here, it's just a wire connection. And on my board, it's just going to be an empty wire. And I'm going to actually make a hold of it, and you'll see the light come on. And what happens is that the signal gets stretched out. In other words, it drops the frequency tremendously. It goes from about 4.5 thousand hertz, so about 4,500 hertz. It drops down to less than 1,000 hertz. In fact, you can get it to drop even a little bit lower than that if you have a really solid connection. But there's a trick to this, because what happens is there's only one wire at the user interface where it says touch here. There is no common to complete the circuit. Well, you are the common. You become what's referred to as the ground plane. And this is where capacitive touch either works or doesn't work well. And we have a number of capacitive touch circuits around that you may not realize. If anybody's got a car where you kind of reach over the handle, but you don't actually touch the handle and the door's unlocked if you have the key fob in your pocket. That handle got a capacitive touch circuit on it. And what it's doing, it's reading as if you're close. Now, I chose the value of 10 million. You have to choose a value of at least 1 million for this even to have a chance of working. Because otherwise you get too much current and it takes way too much drain when somebody touches it to have it shut down. So, and your car might even be using 100 million ohms. Because what happens is the higher the resistance is, the further away you can be from the wire when you touch it. And you complete the circuit. The advantage of your car is the body of your car is a large ground plane. It's connected to the common. It's connected to that negative battery on your terminal on your battery in your car. The problem here is on this microcontroller, the ground plane is very small. Well, right now, it works because I'm plugged into my computer, and my computer is grounded to the house. It's grounded to the house electrical system. If I connect this on the laptop, if I'm running off the batteries, I'm only connected to whatever the ground plane of the laptop is. And if I'm running this off of batteries on something totally portable, I have no ground plane. So in order for this to work, you need a ground plane somewhere, preferably close to where the person is that's going to be touching the wire. to complete the circuit. If that ground plane is missing, it may or may not work for you very well at all. You may not drain enough out of it through the static in the air in your hand, and your body's transmitting that out through the air to ground the circuit. So it may not work very well. So it works really well in a car because the whole body of the car is a ground plane. It works really well on an apartment building or a building that uses capacitive touch for the buttons because you have a large infrastructure of ground around you. If you're doing it on something that's totally portable and battery powered, not connected to earth ground, like most of your equipment is, or doesn't have a large ground plane, it may not work very well. So this is what happens. So this is what we have to keep in mind when we're using it. It's not ideal for every condition, but it will work for a lot of conditions. But let's program it and see how we use it. So I'm going to continue with my existing program. I'm just going to add it to this area up here. But what I have to do this time is I'm going to have to import a file. And luckily for me, I'm going to go up here to the top. Now I know it's going to throw it at the top anyways when I do here. But I'm going to go down here to Sketch. I'm going to go down to Include Library. And you may not see this one here. I've added a library called Capacitive Sensor. And it doesn't look like it shows there. So let me just see. If I scroll this up to about there, I think you might be able to see it. We did libraries. Wow, I got so much stuff here. I'm going to have to lengthen this page at some point. Yeah, I run out of desktop space to show this. So I think you're just going to have to take my word for it that it's down there. Include library. You're going to come down here and you're going to call one called Capacitive Sensor. You can just see it lit up at the very bottom edge of the page. I'm going to click on that, and then I'm going to bring this back down to where we could see it. And what it's done for me, it says include capacitive sensor.h. Well, I'm going to take my comment line, I'm going to cut it, and let me put it above here. And we're going to go ahead and start with that. So it says include capacitive sensor. So when you're looking this up, if you don't have this, and you probably don't, I had to include it with mine. It's not a default item that's in here. You just go to Sketch, you go include libraries, and you go up to the top here and you click on Manage Libraries, and you look for a folder called, in this case, you just search out Capacitive Sensor. And this will allow me to set up a Capacitive Sensor touchpad. So what I'm going to do here is it's going to be set up the touch sensor. So I'm just going to do that. And what I'm going to do here is I'm going to have to do this. So I got to create it, and you have to go into the helper files or find an example, and there are lots of samples for this. So I'm going to go and just copy what I have here. I actually, I took this from another site that already had this done. And then what we're going to do is we're going to create something called Capacitive Sensor so it knows which library to use it from, because it's going to create all the integer types and whatever else is needed for it. And then what we're going to do is I'm going to call this sensor called Capacitive Sensor, and I'm going to do an underscore, and I'm going to put 9, 10 in here. And I'm going to say that's equal to capacitive, we got to spell this right, sensor, bracket, 9, 10. And I'll tell you what this is all about. So what's happened here is I've now created a sensor called CS910. And that's basically what this is down here, a variable. And I've assigned it pins 9. And in the way this is structured for this library is that the first value is the signal that's being sent out. So this is the one that was connected to the 10 million ohm resistor. And pin 10 is the touch sensor. You would do capacitive sensor, give it a new name, equals capacitive sensor, and it would be pin 9, comma, for instance, 11. Meaning that 9 was generating the signal, same one that generated the signal above, but 11 would be your input pin. That would be bringing it in. This one is number 10 is the input pin. So that's what that does there. So we're going to show a little bit more how this works, because what that does is this creates the actual assignment for this one. So that's our touch sensor. So that takes care of the touch sensor. So now what we're going to do is we're going to come down here. I'm going to create one new variable though. And I'm going to create a Boolean value of true and false. So I'm going to call it Boolean, and I'm going to call it touch. And I'm going to start out with it equaling false. And by doing that, I'm just saying it's equal to 0 at this point. But this is just a Boolean. Oh, thank you, Walter. Thanks for sticking around for as long as you can. Hope you enjoy the rest of it later, because you'll want to try a few of these things. So that's basically what's happening here. So that's great. So now I'm going to go in here. I want to see what these values come in at, and we're going to have to do a couple of things here. And believe me, we're not finished setting up everything quite yet, but we're getting close. So what I'm going to do here in my setup, I'm going to turn on my serial monitor. So I'm going to do serial.begin. We've done this before. And what this allows me to do, this is going to allow me to pull up some information so I can see what's happening. And we're going to be able to see it happening inside the program. And then what we're going to have to do down here is we can do this in a couple of places. I'm going to need to create a couple of variables. And I'm going to have to go look at the internal clock. So let me create more variables here before we finish. And this time I'm going to create a long variable. So it's just a long data type with the word called start. And we're just not even going to assign it a value. We're just going to say long start. So we're just creating the variable. And we're also going to create another long variable. And this one is just going to be called total L. And it likes that. And then what it is, it's actually not total L, it's total 1. And it's total 1 because it's the first touch capacitive. If we had multiple touch capacitives, we would go total 2, total 3. So this is going to be our touch capacitive value. Is going to be in here. So that's what happens in here. So that's our two variables we're going to create. And now we're going to go set them up in our program. So let's move down to the loop. I still have my digital reads for my first 2 pins, and I can leave those right where they are. And what I'm going to do is I'm going to include after that now is I'm going to create the rest of this program. So what I'm going to do is I'm going to have to create a value for start. And what that's going to do is going to equal the mils. In other words, how many milliseconds have gone by since we turned on the processor. So we're going to do start equals mils to do that. And then what that does for us is we're now going to grab a total. We're going to do some math here. So this is total 1. And this is going to equal, and this is our variable, CS9, CS underscore 9 underscore 10, which was what we called the variable up top. And we're going to have to put inside of it the function, or what it's going to be. It's not a bracket, it's a dot. This is going to be, and this is where it helps to look up the helper files, because this gets a little confusing when you're doing this for the first time. Capacitive sensor. If I did it right, it came and changed to orange print for me so that I could actually see what's going on. So this is capacitive sensor, and time, and the amount of time is basically 30. That's an input that goes into it, because this is a function within that capacitive sensor helper file that we included, that library. So what it's basically doing is saying, hey, total is going to equal whatever the CSE capacitive sensor set for 30. That's a variable that goes out, and it's going to come back with another value that's going to write it and be what total is. Total 1. So that's what's going to happen here. And then what we want to do is we've done that, so everything else is I want to look at, and I want to be able to create a true and false signal from this. So after I've done this, I'm going to come down here and I'm going to create a new total. So in other words, I want to say, is total true or is it false? And this number we're probably going to have to play with. So I'm just going to say here, total, let's see, total 1. And I'm going to say if it's greater than, now I have an idea what the numbers are going to be right now. We're going to see if this works. But I'm going to say if it's greater than 10,000, then what we're going to do is we're going to do something with that. And we may have to change that value. We're going to find out when we actually run it. This is why I want to bring it out to the serial monitor, because you have to play with this and find it and kind of calibrate it to see what the numbers are for you, for your setup. So what we're going to do is we're going to do that. And I'm just going to say here, touch is going to equal true. And of course, on the other side of this, if it's false, I'm going to make touch equal to false. So I just want to get an idea where it's going to sit. And if I can make it true or false. So I think we'll stop there before we add it to the next part of it. And what I'm going to stop there at doing this part. And what I'm going to do way down here at the bottom, this is just something for my own, after we've come out of this, I'm just going to come down here to the bottom. So this is my writing of my LED. And does it really matter where I do that? It probably doesn't matter where I do this. You know what? I just don't want to create delays between these things going true and false. So I'm going to come down here at the bottom. And what I want to do is I want to find out what my mills are. So what I'm looking at here is I'm looking at doing a couple of print statements. Because we set up the printer, we set up the screen, the serial monitor, now we want to use it. So I'm going to go serial print. And what I'm going to look at is I'm going to look at the mills, at what it was at the start. So what are the current mills minus the start. So that's a variable that we get at the top. So how much time did it take? How much time elapsed when we did this? And then what I'm going to do is I'm going to do the second part is serial dot print ln. And what I'm going to do in here is I'm just going to type in my total 1 value. I want to see what that is in there. And then we're going to create a small delay because otherwise this will be printing way too fast and checking way too often. So I'm just going to put 50 milliseconds in here. It's short. It means it's going to go by pretty quick. But we're going to put all of this in here. And in fact, I think I'm going to add one more print line in here just to make it a little easier to read. Serial dot print, and I'll put in a bracket quote, and I'm just going to create comma space. That'll work better. Quote, comma space, quote, close bracket, semicolon. So what's going to happen here is I'm going to print whatever this value is, how much time elapsed. I'm going to print in a comma space, and then I'm going to print what the total was during that time. How many pulses did it count? And that's basically what's happening in here. And this is basically what it's doing. So if I did all this right, let me validate before I update it in case I missed something, because I did a bit of typing. Nope. Reverse 2 letters here, so that's okay. We can fix that. Serial begin. That's why we validate. And it seems to be happy now. So let's go ahead and upload that. And I'm going to open up my serial monitor. And I'm going to move it to the spot on the page where I can see it. Let me bring it over here. And you can see my numbers are actually not going to be where I want it to be, but that's okay. So what we have going on here is we can actually see a bunch of numbers going by. And I can actually go over here and look at that difference here when I touch that wire. So when I touch that wire, it counts, and I guess it's how long does it take to count 30 counts, I think is what that actually does. So what this does here, when I touch it, you can see how the wire jumps up. But if I barely touch it, it jumps into the hundreds. If I make good contact with it, it gets a little better. If I actually make sure I have really good contact, I'm up at 78,000, so I'm way above that 10,000 threshold. So you can see it varies a lot by touch. Even up here, I'm going to just touch the wire. I'm going to touch the insulation. And look at that. Even with doing that, I was able to get that to 500 and 600 numbers even with just touching the insulation. So in other words, there, if I barely touch it, I can touch it and make it do 100. And I'm just barely touching that wire. If I used a higher ohm resistor, it would even become more sensitive. So this is where that sensitivity bit comes in. But I can actually see some numbers, and if I touch that, we can see some really big numbers there. So easily it's not mistakable that I'm trying to touch it. So far, let me just move that back in there. We can see that this is all doing it, and there's nothing connected at the end of this wire. It's an empty wire. So when I put my fingers and I close it on there, again, it touches and it works. So we can see that we're getting quite a value difference. So let's go back into our program here and make one more change, because we now know whether it's true or false. When it's true, it's over 10,000. So let's go in and turn on our LED now. So I'm going to add another OR, and I'm going to include the word touch. So if touch is true, turn on the LED. If it's false, if all of these are false, turn off the LED. So that's basically it there. So I'm going to go ahead and save that now. And if I've done this right, we've got the little tiny LED up here in the corner. So there it is there in the corner. On your screen, if I press the button, the light comes on. I press the other button, the light comes on. I touch my capacitive touch, the light comes on. So we can actually do this. If I touch multiples, it doesn't matter which one I'm touching at a time, the light will stay on. So there we go. So there's a capacitive touch circuit. So we were able to get this to work using capacitive touch. Capacitive touch took a little bit more programming to set up, but you can see it's a very simple circuit on the outside. It used that to show you the circuit again. Here it uses the 10 million ohm resistor going across it. It comes out to a touchpad, and what it does, it changes the signal from being this tight, multi-pulse, very fast, to a very slow. Makes the difference in here. So it's working, which is probably pretty good. So we can see that. I'm going to turn that back off there. Actually put that serial monitor back up there again. When I touch these wires, you can actually see, again, that's happening, and the LED is turning on. So it's doing its job. So it actually worked. So hopefully that explains how capacitive touch works. Now, of course, what I want to do is I want to show you what's involved. Other version of it in CircuitPython, because it's done slightly different, like everything else. I'm going to explain it. The majority of the show was spent building this. This is actually the hardest part to build. So let's go and have a look at how it does it in CircuitPython. So I'm just going to turn off my Arduino screen. And I'm going to turn on my Mu editor, and let me change out what's in the screen here. And in fact, we're going to zoom in one spot. And we're going to get this lined up in the camera. And there we go there. So I've already pre-wired this one. So let me go look at the program. This is online right now. So what I can do here is I'm going to go up here and I'm going to load, and I'm going to load it right off of that card, off of that G file there, and I'm going to say open, and here's the finished program. I've already created this ahead of time. So I'm going to make life easy for us here. So this is just an input test. Again, this is what I have here. This is using the Arduino M4 Express, and it says required helper files, time, board are two common ones. Digital I/O is what we're using for our push buttons. So we're from the digital I/O, which is an internal file. We're going to import digital input, direction, and pull. So it's actually going to set, these are all the things we have to do. Is it an input or an output? And are we pulling it? And yeah, we're going to pull up. And then there's also import touch I/O. Touch I/O is also built into the main file because touch I/O is pretty common in the CircuitPython line of things and with these newer microcontrollers. So unlike Arduino, where we had to load in a separate library from another source, this one actually has it in there. We just have to say, okay, I want to use it. And it's there. So let's look up a few things here. So let's set up the LED. When we looked at the original program inside of here, inside of Arduino, what we did is we set up, first of all, a pin assignment for the LED. And that's what this first line does. LED equals, and it says digital input or output, board pin D13, digital pin 13. And that's exactly what it's doing. The next line says LED is the variable, set the direction. So we're going to set the direction variable within LED now to direction as an output. That's it. It used it. It was no different than putting in pin mode in the setup file. So this was pin assignment and then the direction, what we want to do with it. Push button 1, same thing. It's an input output. It was connected to D5 in this case, and the direction is just an input. And that one has on here, that's going to be this one that's actually closest to the board here. And that one that's closest to the board actually has a resistor up above it, up in this area. So you can actually use it and with this circuit. It comes in on the white wire, just like it came in on the white wire in the other one. And then the third one is this one, the other push button. This is a normally closed input, it says here, because it's, first of all, it's pin assignment D9. It's going to have a direction as an input, but then we're going to do a pole. We're going to set the pole parameter, and we're going to set it for pole, and we're going to set it for up. The reason why we put it for up is because we can also use pole down in CircuitPython. So this particular board, and it is board related, it is not program related. This one has a pull up and a pull down setup within the chip. So we can do both in this chip. Whereas in the Arduino, we can usually, on the Uno, we can only do pull up. There are other ones we can do pull down on as well. And then we're going to set up the touch pin. So here's your touchpad. We're going to connect it. We did not connect it to a digital pin like we did in the other one. We actually connect it to an analog pin. So that's a little bit different. We're actually going to read the analog value in. It prefers to use analog value. And we're going to say touch in, and we're going to say touchpad. By doing, and this is the touchpad up here. So it's going to use that pin. It's going to create a variable called touch. But because we used touch in, it automatically sets up that generated signal on the pin for us. And therefore, we don't need to do all the stuff we did before. We don't have to worry about how the signal works. We don't have a second pin creating the signal. It's already being created on the pin. All we do is we have to create a ground to it. And it's wired up slightly different. And that's over here. And this is the analog pins back here. Is on the green wire. I have my 10 million ohm resistor on this particular board. I have it going to common. So I put the 10 million ohm resistor in here because it's not built into the feather. Remember I said before I wanted to introduce this board at the proper time? This is the Circuit Playground Express. The majority of these input and output pads on here are also touch capacitive. The difference is on this particular board, this is the I guess turn it around this way. Circuit Playground Express, the high meg ohm valued resistor is already built into this board. It's already internal in here. It's not required. You don't have to do anything else, and it works just fine. So that's the advantage of something like that. So it's just another family of the same types of boards, same types of chips, but you don't need the external resistor with it. This one, it prefers if you add the external resistor to work properly. So that's what we did. Now, there is no setup in this one here like we did before because setup is already pre-done as part of your assigning the pins. That's all in one combination. So let's have a look at the main loop. This is the whole main loop. It's actually shorter than what it was in Arduino. So what we're doing here is we're looking at if push button 1, and in order to bring in the value, we use the dot value button, and that automatically reads it. So it actually reads it. We don't have to create a separate read statement. And we can say, in this case here, we don't use the double bars going up. We use the keyword and just type in the word or. And then we use the word not for the reverse condition for push button 2. Or we have a touch value. And because it's already set up internally, where I set up a parameter where I wanted it to be over to read that and I can adjust it, this is already preset. We don't have to set a value. It knows how to handle capacitive touch within the chip. So it figures out what it should be anyways. And then we just say, if that's true, turn the LED on. Otherwise, if it's false, if none of these are being pressed or activated, make it false. And then what we have down here is we got the button down here that says print a message if capacitive touch active. And we say, yeah, it's touched. And I never even printed a value for it. I just say it's been touched. And then I create a slight delay. 0.05 is 50 milliseconds, just like delay bracket 50 close bracket is. So this is the same amount of delay time as the other one. So let me turn on my serial monitor. Let me save this. And when I do, we can see nothing's happening there. If I touch this, it says it's been touched. And when I let go, it's not. Now, LED 13 is up in this corner, right by the plug. So when I press the first push button here, the light comes on. We can actually see, there's the light right there. The light comes on. Press the second push button, the light comes on. I touch my wire, and it comes on. If I don't touch it, it goes off. In fact, I'm actually getting a signal through here just touching the insulation. So you can see we're getting a partial signal. And if I squeeze that, it doesn't get any better. But as soon as I touch the bare metal, I can get it to come on solid. So this works just like the other circuit did. Ever so slightly different. Definitely a shorter program. So we were able to do this within a shorter program. This is a much shorter program than the other one was. So there's less to set up in here. It's less complicated in the CircuitPython, but that's the board we're using is more modern than the original Uno. So a lot of those features are already built in. So that's what happens when we're using capacitive touch. And I just wanted to show the difference between them. They are similar. We can do the same features regardless of which board we're using, regardless of whether you were using analog inputs for the feather in this case, or we use a pre-designed input if we're using the Circuit Playground Express. We don't have to do anything to it. It's really simple, just assign the touch point, and it can be on A1, A2, because all of these inputs, not only the analog, most of the inputs, but they're also digital as well. The same thing goes true on the board. Any of those analog inputs can be used as digital pins as well. You can do in analog, you can do input in. You can use them as digital in pins on the Arduino as well for the analog ports. So we do have some choices on what to do here. It saved us one pin because the generating signal is already built into it. So we didn't have to play with that. But everything else, it basically works the same way. It allows us to use a push button without any anything on it. We can use a push button with an external resistor connected to it so that we can do an external pull up, which is the preferred way of doing most signals. We can do an internal pull up on any of these boards, and we can also do capacitive touch. Capacitive touch, like I said, has some limitations on the ground plane. That common plane is what's so important when you get into capacitive touch. Okay, other than that, I think that's going to wrap it up for this time. I've actually covered all the topics I wanted. I'm going to zoom back out my camera here. Only because to show you that, hey, both of these are running. Oh, I might be able to zoom in one spot. Let's see. You can kind of see it in here. That LED is still coming on. It's between the red and the black wire there. I'll push them down out of the way. They're probably going to get in the way again. My capacitive touch works on it. My capacitive touch works on this one. My buttons still work over here. So, whether you're going to be working with Arduino, this one over here, or whether you're going to be working with CircuitPython with a board similar to the Feather, you can do all these types of features. and it gives you a better idea how inputs work. There are multiple ways of hooking up an input depending on your circumstances and what you prefer and what you get used to. I would strongly suggest that you try it, play around with it, see how the differences work using internal and external resistors, compare the differences, see which one you prefer, which is better for you. And that's what matters. It's your program, it's your project that you're going to be working on. Use the type of input that's best for you. Until next week, and until later, I'm going to say thank you very much for watching my show today. This was episode 8, Push Buttons and Touch Inputs with CircuitPython and Arduino. I'd like to just say thank you. Remember to follow me on Twitter at kingernorth, or you can also subscribe to my YouTube channel, youtube.com/kingernorth. And if you subscribe, you can also set notifications. I am starting to get to the point where I'm remembering to, when I'm going to create a live stream, I create the event ahead of time. And basically up to 24 hours before, it will actually send you an email if you're subscribed and you have notifications turned on. It will actually send you an email reminding you that here's the show, and in there I usually it has the new title and whatever information, so you can get it ahead of time. So until next week, I'm not sure what next week's topic's going to be, but we'll figure that out before then. Thank you very much. Have yourself a safe week. Enjoy your electronics and play with it. Give it a try. Goodbye, everybody.